All right, today we're going to be talking about the history of life on Earth. So this is a brand new chapter, brand new section, so I definitely recommend starting a new page in your notebook, okay? Big nice heading, you're going to write down history of life on Earth, okay? So that's going to be your heading. We watched a video, or we're going to watch a video on the beginning of life on Earth, okay? You guys I've seen lots of different things. We're talking about how life on Earth got started, but in order to do that, we need to talk about how Earth itself got started. Okay? So if at any point you need to go slower, just raise your hand and ask the sub to stop the video or pause the video, and you guys can write down the notes. Okay? All right. So this is the first thing you need to write down. Okay? Let me make this a little bit smaller. Earth formed 4.6 billion years ago. Okay, I just need you to write down this sentence. Earth formed 4.6 billion years ago. Okay, in your foldable, you guys already talked about how it formed. Okay? Your foldable says many collisions occur with rocky debris in the solar system. So you already have that written down. Okay, so what happened here is that gravity, there was a whole bunch of stuff flying around space, okay, from the creation of the universe, okay, the Big Bang. So all these particles, all of these rocks were flying around. And if we look at this picture here on the right, we see there's some gravity and it's allowing these things to circle or orbit around the sun. And as they keep orbiting, they bump into each other and they make bigger planets or bigger masses until finally we get the planets that we see today. So this is 4.6 billion years ago. Does anyone know how many zeros a billion has in it? A billion is 9 zeros. And I'm actually not going to write that down, okay, because it would take too long. But I'll type it out. So 4.6 billion years ago looks like this. So that is a huge number, okay? So this was when Earth formed, all right? Now, what was early Earth like? I will let you write these down in a second. I'm just going to hide them right now. So I need you to write this down. What was early Earth like? And you guys saw some different things in that video. You saw it really hot. You saw lots of volcanoes, certain gases. So first thing is that early Earth was full of poisonous gases, okay? You definitely don't need to write these words down. They're just examples, okay? So examples of the poisonous gases, carbon dioxide, sulfur dioxide, ammonia, but they were poisonous, okay, to living things today. The living things weren't around yet. It was full of poisonous gases. There was also lots of lava. It was really, really hot on Earth. So there was tons of lava. A lot of the rock was molten or magma or lava because it was so hot on Earth. There was no oxygen. So humans and other organisms that use oxygen wouldn't have been able to survive. So no oxygen for organisms. It was super hot. Because of that, there was no water. Okay, what happens to water when it gets really hot? It turns to steam, right? Okay, so there was no water, okay, and even when we did get water, it actually wasn't liquid water, it turned into steam. But originally there wasn't any water on Earth. I had asked you guys what happens or what caused the water to be on Earth. And you guys had a lot of different ideas. Okay. We'll figure out where water ended up coming from shortly. Okay. So there's no water. It was super, super hot. And there were many asteroids and comets that were hitting the Earth because remember there was all of that debris circling around the sun? Well, a lot of that was just a whole bunch of debris from the beginning of the universe, a whole bunch of rocks, and so there were a lot of extra rocks that kept hitting planet Earth. So because of this, okay, we couldn't have a lot of life. There was no life on Earth because it was such a terrible environment for living things, right? There couldn't possibly be anything alive. So then, how did the continents form? Okay. So we have lava cooled and formed the first parts of Earth's crust. Okay. Again, you have this written in your foldable. So you don't need to write it again. If you want to write it again, you're more than welcome to. Okay. So lava cooled and formed the first part of the Earth's crust. All right. So we see down here, right? The crust is actually the outer part of the Earth. Okay. So the lava cools and it forms the outside. So now there's land. It's not just lava. Okay. Now remember we talked about water. So water actually came from meteorites. Okay. So it came from meteorites. But when those meteorites hit Earth, that water was vapor. It was like steam because it was so hot. Well, when Earth started to cool down, what do you guys know about water from the air when it cools down? For example, if you have like a Tupperware of food and you put it in the refrigerator and it's still warm, what happens when you pull it out of the refrigerator? What's on the inside? A whole bunch of water, right? So all of that steam turns into liquid water. Well, the same thing happened on Earth, okay? So all the steam in the air turned into clouds, which produced rain, and that rain ended up filling our oceans. So before this time, there weren't any oceans. Okay, there were just big craters or big empty areas. It was all land. So as the earth cooled, water vapor from the atmosphere condensed to form clouds, which produced rainwater that filled the oceans. Again, both of these are in your foldable. If you would like to write them down, you can. Just ask the sub to pause the video if you need more time. Okay? So when the crust cooled, all right, it formed these continents, okay? So the continents didn't look like they look like today, okay? So you need to write this down. The crust continued to form, making a supercontinent, and that supercontinent was called Pangaea. So go ahead and write that down. So if you look, here's Pangaea. This is 225 million years ago. When did the Earth form? 4.6 billion. This is million, okay? So this is pretty recently. And then notice they split apart more, and then today we have separate continents, okay? So Pangaea was the name of the continents that all were ended up smushed together. You guys will be learning more about that later. So you might ask, well, how in the world do we know that these continents fit together? How do we know that they fit together? We weren't alive back then, so how do we know? Well, we have some different pieces of evidence, okay? We've been talking about claims, evidence, reasoning. Scientists have evidence, okay? Like proof. So we need to write down the evidence for Pangaea. So go ahead and write these down. The first piece of evidence is the fact that we have fossils. And these fossils are found on different continents, okay? So I'm going to blow up this picture. I'll move it back in a second. But if you look, all right, this is the Cynonathus, okay? Cynonathus, and he lived in South America and Africa here. And notice if we line up South America and Africa, the fossils are found in a similar area, right? So scientists found these fossils and they were like, hey, these are in Africa and they're also in South America. How the heck did they get there? This guy can't swim. Does he look like a swimmer to you? Nope. So how did they get there? And they said, well, maybe the continents had to be together at one point. Or like this guy, Lystrosaurus, okay? He was found over here in Africa and India and Antarctica. They were like, what the heck? Why did he live in Antarctica? How did he live in all three places? He couldn't swim. So they said, well, you must have lived there when all of the continents fit together. Same thing with mountain ranges. When we put the continents together, there are mountain ranges that span and across continents. They match up. And then they just look like they fit together, right? We're going to do a puzzle where you guys see that they really do fit together. So this is why scientists believe that Pangaea existed. All right, and then lastly, we have the theory of plate tectonics. So you might be like, Ms. Frankson, okay, great, the plates moved, but how did they move? Well, we have plates on our Earth. Okay, Earth's crust is divided into plates, and they travel over something called the mantle. Okay, so basically underneath the crust, we have this kind of liquid layer of rock, kind of like lava, and the plates can move on this liquid layer. Okay, and this liquid layer is called the mantle, right? And these plates are still moving. They only move like an inch every year, so they're not moving super fast, okay? But they're still moving. So eventually, if we go like 200 million years into the future, our continents might not look like our continents. Maybe they'll be smushed together again. Maybe they won't. Maybe they'll be in a different pattern, right? So these plates are still moving. And plate tectonics is what caused Pangaea to break up into the continents that we know today. Okay, you'll also hear this referred to as the theory of continental drift, okay, or the idea of continental drift, the idea that the continents drifted apart from when they were in Pangaea. Okay, so that's all I have for you guys. Okay, if you need more time to write this down, just have the sub pause the video and have a great rest of your day.